Welcome back to part 2 of expectation values. We started this lesson last video and we've broken this up into several different videos so it's a little bit easier to grasp. So in this part, we'll be looking at some real world examples and just some that are a little bit more complex than what we dealt with in lesson A. Let's begin. Example 1. Cottage Grove, some city, is deciding whether to keep stop signs at the intersection of Jamaica Avenue and 70th Street or to change the stop signs to stop lights. After some research, the city discovers the following. With stop signs, crashes occur 4.5% of the time. And for each crash, the city pays on average about $750 for repairs, with an annual maintenance for that intersection of $1,500. For stop lights, crashes occur much less, only 1% of the time, but for each crash, the city pays on average $3,200 for repairs, and the annual maintenance for stoplights is $11,000. The city continued to do some more research, and they expect that there are going to be 8,000 vehicles to cross the intersection next year. What is the expected cost for each of the choices? Okay, so let's begin with stop signs. Well, there are 8,000 vehicles that are going to cross this intersection each year. If crashes occur for stop signs 4.5% of the time, I need to first figure out how many crashes are going to take place. So, of the 8,000 vehicles, we're going to multiply this to 4.5%, so that'd be 0.045. Or you could do 4.5 divided by 100. So 8,000 times 0.045. Okay, I'm expecting about 360 crashes. And to show you, you can do the same thing by doing 8,000, and instead of multiplying by 0.045, we could do 4.50 divided by 100, because this is 4.5 out of 100%. And you'll see that you end up the same thing. All right, so for each crash, the city pays for $750 in repairs. So that's going to be 360 crashes times $750 for each repair. So that's going to be 360 times 750. This is going to be $270,000. All right, plus the annual maintenance. So then we've got annual maintenance is $1,500. So the total cost for stop signs is going to be $270,000 plus your annual maintenance of $1,500 for $271,500. All right, now we're going to do the same thing for stop lights. Crashes here occur 1% of the time. So I'm going to do the exact same setup. I've got 8,000 vehicles. And I need to multiply this by 1%. So 0.01, or you could do times 1 over 100. So 8,000 times 0.01. I'm only expecting 80 crashes with stoplights. Now, with those 80 crashes, though, it's a much higher repair cost. So I've got 80 crashes times, for each one on average, it's $3,200 for repairs. So I'm going to take this 80 and multiply by 3,200. This is 256,000. And then there's the annual maintenance. And that is 11,000. Okay, so the total cost here is going to be 256,000 plus another 11,000 for a total cost of $267,000. Or in other words, it would appear from the information that we're given that stoplights would be less costly to install for the city. Example 2. You're at a carnival. They have a batting cage where 2 games are played. Each game costs $10 to play, so it's a little steep to play this game. Which of these 2 games is better to play from a mathematical point of view? So, game 1. There are 3 slow pitches. If you hit all 3, you win $50. You estimate that because of how slow the pitches are, you've got a 65% chance of hitting each pitch. The second game is 3 fast pitches. If you hit 2 in a row, you win $100. Because of how fast these are, though, you estimate that you've got maybe a 30% chance of hitting each pitch. So let's analyze each of these games individually, starting with the slow pitch game. The probability of hitting one pitch is 65%. So we're assuming that for both of these games, you're, I guess, kind of like a machine. You don't get tired, you don't slow down, you just keep going at 65% for game 1, and you keep going for 30% for game 2. Well, the probability of you hitting all 3 means that you would have to hit the first one, and you'd have to hit the second one, and you'd have to hit the third one. So what that means is you'd multiply 0.65, 65%, times itself, and then times itself again. Okay? To win the slow pitch challenge, this is hit, hit, hit. You have to hit all 3. Hit times hit times hit. This would be 0.65 times itself, and then times itself again. So 0.65 okay, and then since we're multiplying to itself and then itself again, this is the same as saying to the third power. the probability that you win is a little better than 27%. This is 0.2746. Okay, so the probability that you win is 0.2746, which also means that the probability that you lose, since you either win or you lose, there's no other outcome that could happen, it would be 1 minus the probability that you win. So the probability of lose is 1 minus the probability of winning. So this would be 0.7254. So a little more than 72% of the time you would lose this. All right, now we've got the probabilities. We've got what the outcomes are. If you win, you get $50. If you lose, you get 0. And we have the costs. So we have everything we need to find the expectation value. Remember, the expectation value is the sum of the values of each event that could occur within that game. So we just need to know what is now the value of you winning and the value of you losing. We'll add those together, and that'll be the expectation value of this first game. So let's do the value. Separate this a little bit. The value of win, that's going to be the probability that you win, 0.2746, times the outcome is I win $50, minus the cost is $10 to play. And then we also need to know the value of losing. That's going to be the probability of losing. So 0.7254 times the outcome here. Well, I just lose, so I get $0, but it still costs me $10 to play. All right, let's put this in. 0.2746 times the outcome is $50 minus $10 to play. So the value of win is 10.984. Now the value of lose is going to be 0.7254. The outcome here would be $0 minus it still costs $10 to play. All right, this is negative 7.254. Now I want to know the expectation value of this game as a whole. So that means now that I've got the value of each possible event, I'm going to add these together to find the expectation value of the game. All right, that's going to be this plus this. 3.73. In other words, if it were possible for me to play this game forever, I never get tired, I would expect on average to win about $3.73 per play. That seems pretty good. If it were possible for me to do this, I would just keep playing this game and racking up wins to earn some money. But let's compare to game 2. Is game 2 any better? So we're going to do something similar. We need to know what's the probability of winning, then what's the probability of losing. We already have the outcome for winning, and we already have the outcome for losing as well as the cost. Okay, so in order to win this game, I have to hit 2 in a row. Okay, so I have to hit 2 in a row out of 3 pitches. So let's write down everything that could happen. I could get a hit, and a hit, and that would be a win, okay? Because I get at least 2 out of the 3, okay, in a row. I could get a hit, and then a miss, and that would still be a win because I get 2 in a row there. But if I do hit, miss, hit, that's a loss because it's not 2 in a row, even though I hit 2 of them. And if I do hit, miss, miss, that's a loss because I only got 1 of them. Didn't get 2 in a row. I didn't even get 2 hits. All right, then what else could happen? Let's see. I could do miss, miss, miss. Of course, if I miss all 3, I would lose. If I do miss, miss, hit, I only hit 1, so I don't win there. If I do miss, hit, and hit, that's a win because it's 2 in a row, even though I missed the first one. And then if I do miss, hit, miss, that's a loss because I only hit 1 and it's not 2 in a row here. So there's only 3 of these scenarios in which I win out of the 8 in total. So what I want to do is I want to calculate what's the probability that hit, hit, hit occurs. What's the probability that hit, miss, hit, or hit, hit, miss occurs? And then what's the probability that miss, hit, hit occurs? Because if I add those together, that'll be the probability that I win in general. So let's do that here. So probability of hit, hit, hit. Since I have a 30% chance of hitting each pitch, this would be 0.30 times 0.30 times 0.30 because I'm hitting each one of these. Okay, 0.30 times 0.30 and then times another 0.30. So that probability is 0.027. Okay, what about hit, hit, miss? Probability of hit, hit, miss. If I hit the first one, that'd be 0.30 times if I hit the second one, that'd be 0.30. If I missed the third one, that'd be 0.70, since hitting it is 30%. Not hitting it, missing it, would be 70%. Okay, I'm going to copy that one and just change that last one to a 0.30 to 0.70. And so this probability is 0.063. And then lastly, the probability of miss, hit, hit. So if I miss the first one, that'd be 0.70, and then the other 2 are hits. So this would be 0.30, and this would be 0.30. Now this should be the same as hit, hit, miss, right? So if I just do this here and then now change the first one, I can show you that. And it is. So this is 0.063. So these are the 3 ways I could win. I've calculated the probability of each of these ways I could win occurring, which means that the probability of just winning in general is adding these together. So the probability of getting a win is 0.027 plus 0.063 plus another 0.063. The probability of getting a win is 0.153. Now, just like I did up here, the probability of losing then is going to be 1 minus the probability of you winning, since winning and losing are complements of each other. So the probability of losing is the probability of winning, 1 minus the probability of winning. Okay, so then 1 minus 0.153 is 0.847. Now I've got the probabilities of winning, I've got the probabilities of losing. I know the outcome, $100 if I win, $0 if I lose, $10 to play. So let's find the values of each of these and then the expectation value as a whole. So I need the value of a win, and I need the value of a loss. The probability of winning is 0.153 times the outcome. If I do win, I get $100 minus it costs $10 to play. Okay, then the value of a loss. So this would be the probability of losing, 0.847, times the outcome. Well, I get $0. I don't win anything, but it still cost me $10 to play. $0.153 times 100 minus 10. So the value of a win here is 13.77. Okay, what about loss? This is 0.847. Okay, and then times 0 for my outcome minus $10 to play. This is negative 8.47. Which means, now that I've got the value for all the possible events here, let's add them together to get the expectation value of the game. All right, the EV of this game, add these together, 13.77 plus negative 8.47. This gives me an EV of 5.30. Or in other words, each time I play, I can expect, on average, to win about $5.30. If I compare the two games then, even though the chance of me winning is lower, right? The probability of winning fast pitch is 0.153 versus the probability of winning slow pitch is 0.2746. The probability of me winning fast pitch is lower. The balls are being thrown much faster. It's harder for me to hit them. Because the payout of winning is so much greater, the expectation value is better there. So it's better to play fast pitch versus the slow pitch challenge. Hope this helps out. There's going to be one more section on expectation values. Be on the lookout for that video coming soon.